So we're just going to have a little talk about work, energy and power. Now with energy, the units are joules, and the definition for energy we use is that it's the ability to do work. So the physics definition for work then is equal to force multiplied by distance. So energy is anything that can cause a force or cause a body to move, or cause an acceleration. Energy is pretty much all around us. Now there are many different forms of energy, so I might just list them now. You've got kinetic, which is movement. Anything that moves has energy. Potential. Now generally you're talking about gravitational potential. So anything with height has gravitational potential energy, because if you drop it, it'll move, it'll accelerate. We've got thermal, which is just heat energy. Chemical, so it's the energy which causes atoms to bind together and whatnot, and chemically combine. So this is for chemical reactions. We have nuclear, which is the energy which drives nuclear power stations. So this is very much an atomic scale, and it's also responsible for the sun's energy, and indeed the temperature in the core of the Earth. Then we have electromagnetic, and we'll be doing this topic in more detail, but electromagnetic energy is responsible for all light and electricity. And I think there's probably one final one, which is sound energy. Sometimes sound energy isn't included in this. It's the energy of sound waves, because sound energy could be broken down into kinetic, because it's pretty much the movement of particles. So those are the 7 different types of energy that we're dealing with anyway. 1, 2, 3, 4, 5, 6, 7. Okay. Now the real important thing from this is, well, one of the most important fundamental laws of physics is the conservation of energy. And that states that energy cannot be created or destroyed, but can only change from one form or another. So energy cannot be created or destroyed, but can only change from one form to another. Now this is a massive law, and it's relevant to pretty much everything, and it's really one of the fundamental underlinings of physics, is the conservation of energy. What it means, and if I just do a little quick example there, if I have a rock here, I'm holding it in my hand, it has potential energy. Now potential energy is given by, and generally write EP is equal to the mass of the object times the acceleration due to gravity times the height. Now if I let that go, it'll fall, and as it falls it'll accelerate. Now once it starts moving, it changes from potential energy to kinetic energy. Now kinetic energy is given by EK is equal to half mv squared. Potential energy up at the top there, just minimize that. Potential energy up at the top there is equal to mgh. Now what this means, the conservation of energy means, is that as this ball, as this rock falls, it loses potential energy because the height is going down, but it gains kinetic energy because the velocity is increasing, because it's accelerating. Now as that falls, and as it, before it, up until it hits the ground, the kinetic energy plus the potential energy is equal to a constant, which is the maximum amount of energy that it had up at the height here. So as this decreases, this increases, the kinetic energy increases to compensate. Now this is just a very small example of the conservation of energy. Now just to bear in mind that when the rock hits the ground, the kinetic energy is lost. It's converted into sound energy. There could be some slight vibrations through the ground then as well, and yeah, so the energy would dissipate out further. But it's very important to realise that the energy is not destroyed, it is just changed from one form to another. So in this, what we've covered was, number one, energy, the units are joules, it's the ability to do work, and work is given by force times distance. Now work and energy are almost equivalent. We've got the 7 different forms of energy. Now in this topic we're really interested in kinetic and potential. Now the conservation of energy works for absolutely every bit of physics, and it underpins a lot of physics. Energy cannot be created or destroyed, but can only change from one form to another. So that essentially says that there's a limited amount of energy in this universe we have. Now when a stone falls, it loses potential energy and gains kinetic energy, but it's important to realise that at any point as it falls, the total amount of energy remains constant, in line with the conservation of energy.